So one real quick order of business. We didn't think Joe was going to come, so his name's not up on the screen, and it was taken down from the website. But he showed up yesterday, and we were excited that he was able to make it. He's a super crucial member of this crew, and yesterday when I pointed out to somebody that he was here, they said, "Where is he?" in front of Joe's tobacco station, and that is in fact where he was. And so I'm Luke, I'm the moderator. I'm very much the new guy in this panel. I arrived at Salon last March. I never was able to work in the office, so I'm happy to share some of these traditions, but I have visited the office since then. And I'll tell a quick story about my past with that building, but I want us to talk about the future, just because it's kind of a funny story to me, at least. I lived in San Francisco a long time ago in the late 90s and had a couple of different jobs. I briefly worked at an early kind of version of a digital agency in maybe 97 or 98. And when I saw the Tlon address, I was pretty sure it was in that same building. And when I arrived there for the first time this summer, I was like, yeah, this is the building. And I only worked there for a short period of time. And I think in the first couple of days, I realized that the real way they made their money was actually for a website that they were running, not the websites they were building for things like, was it PG&E and these other big utilities. It was a website called The Naked Sword. And don't go to that on a work computer. It's still up. Anyway, we've heard a lot about the future from other folks. I would really like to give everyone on the panel a chance to talk about the things they're excited about building. Because even within Talon, while we're building this thing that we want to outlast us, we're all kind of after something that's a little bit different within this elegant system. And so I think it's just interesting to kind of hear these different versions of that. We'll just go left to right. Like, why not? Okay, Joe says no. Ted?
Okay, I can go first.
How's the sound? Tell us who you are.
Good? All right. What I'm excited about for the next couple of years is... Oh, yeah, sorry. I'm Ted Blackman, rovnys-ricfer. I've been one of the core devs working at Talon Corporation for a little over 5 years. And so what I'm mostly gunning for, personally, is getting to the point where a developer can write an application on Urbit, write it once, publish it to other nodes on the network, and then have that run correctly forever. So this is something that Urbit has always implicitly promised through the Kelvin versioning scheme, which you've probably heard of. Urbit, the versions of the kernel have decrementing version numbers going down to 0, after which it will be considered a standard and will never change again. But that's actually not exactly the same thing as what I'm describing. And in particular, I want us to, Kelvin versioning, that's going to take us between 20 and 200 years, roughly, for those to go down to 0. That's the plan. But we want to hit indefinite future compatibility that I'm describing with applications within 2 years. So in order to get there, we need, from a sort of, the immediate thing we need in order to get there is just a way for a kernel to emulate an old kernel so that it can keep an old application running. That's not that complicated, so we can do that. But the reason it's going to take us a couple of years to get to that point is that the Urbit application model doesn't do everything that it needs to do long term. In particular, it's missing, in my opinion, it's missing 2 key components, which I talked about last year at last year's assembly, and we've been working on both of them, and that's scaling and hardening. So normally when we talk about hardening, it's like security, right? So most of the difficult security work is actually not in the kernel itself. It's in the runtime and relays and HTTP stuff and these sort of, but within the Arvo kernel itself, the kernel of the Urbit operating system, it's relatively easy to put that sort of thing together because it's all pure functional. So you look at, well, what inputs are there to the function and what outputs are there to the function, and just look at each one of them and say, are you allowed to do this? So we have that part of it. So we call this a user space permissioning system. It looks a lot like the iOS permissioning system, right? You install an app, it's like, can it use the camera? Can it do other stuff, right? So there's an Urbit equivalent of that. It looks a little bit different because Urbit is a server. So we're going to have to iterate on that. But it's a relatively small component. We're in the process of building it at the moment. That's one thing that we need, but it's not part of the application model. When you go to write an Urbit, Gall application, a Gall agent, that doesn't show up. So it will soon, but we need that. And so if you wrote an application now that doesn't have anything to say about its permissions, its capabilities, what it's allowed to do, then we probably can't keep that running forever because we need to actually have some constraints on that. So we have to get that kind of interface to the point where it's secured, and only then will we be able to keep that application running forever. The second thing we need is scalability. So Urbit is not web scale, and in order to get it there, we need a few things. One of the big things we need is the ability for one person to run their ship and publish data to a very large number of other ships efficiently. That should be something that should sort of elastically scale up, like a content delivery network, where that should just sort of seamlessly work, right? Someone, like what happens on Twitter or something like that, where if a tweet goes viral, that can go to millions of people very quickly, right? So that needs to be able to happen with Urbit. We talk a lot about localism, but we also need that to happen, right? Urbit is a worldwide network. We do want it to support having lots of people on there, and so that's a critical feature. So in order to have that kind of scalability, we need a network protocol that can implement that. So we have that designed and built, and we plan on releasing that by the end of the year. So that's called FINE. It's F-I-N-E. It's named after the French mathematician and cartographer Laurence Finet, and it's a remote scry protocol. If you ever need me to talk your ear off for 3 hours, I'll tell you all about Urbit's scry namespace. Happy to do that. So it uses Urbit's scry namespace. But in any case, it's a way of having many different ships read data off of one ship in a way that scales very well. So we have that network protocol implemented. We haven't released it yet. We'll release it soon. But not only do we need the protocol implemented in the kernel, we also need a way for applications to hook into that. So we need a way for them to publish data into this namespace, and we need a way for them to subscribe to data from the namespace. All right, so that's how a chat message should go from the chat host to everybody else, for example. So in order to do that, that also requires some major changes to the interface between applications in the kernel, the user space kernel space interface. So this is Urbit's equivalent to the Win32 API in Windows. And you may have heard of Linus Torvalds being very vituperative about don't break user space. And that's exactly what I'm talking about here. So we are going to have to break user space a couple of times because we're going to have to add the capability for applications to hook into this scry namespace on the publisher side and on the subscriber side in order to use that scalable network. But once we have those two components, once we have a user space permissioning system and an ability to hook into the remote scry protocol, and we're calling that system solid state subscriptions by analogy to Urbit's solid state interpreter. Once we have those two components, then I'm convinced that we'll be able to commit at that point to saying any application that uses those two things will be able to keep that running forever. So after that, there will still be many iterations. There's still a couple of hundred versions, Kelvin versions, that we'll need to go through before we can say, yes, Urbit is this perfect crystalline, tiny diamond of a piece of software. But we can still build emulation layers for the older system once we hit that point. And so that's why I'm saying about 2 years from now, that's where I want us to get to. And that's what I'm gunning for.
Thanks, Ted. And just so everyone who's... Sorry, go ahead. a lot of that work is happening now, and that is also a material portion of the roadmap for the sort of medium-term future. Anyone who's building on Urbit, Ted may have said something that scared you. We will break namespace. We're also standing up stronger developer community relations, so people know this stuff is going to happen. I've already been in touch with folks who are super active as developers. Please reach out to me if that's something that you want to be part of, but we'll also be publishing that out more broadly.
Yeah, and actually I can add a little addendum to what I just said, which is that before we can make that full commitment to saying we'll never break user space, we can start breaking it less and less frequently and make it easier to stay compatible. So it's not just a binary switch that gets flipped at some point, it's a process of getting there.
Yeah. Awesome. Philip?
Yeah, I am Philip Monk. I've been around Urbit for a long time. Learned about it in 2013, joined Tlon in 2014. And for a while there at the beginning, I didn't know what Urbit was for. I was just like, well, it's more fun than school, so I'll do that. And I left for a couple years, and when I came back, I was like, okay, actually, no, I know what Urbit's for. I know what I want it for. I have a purpose to work on this for as long as it takes. And so, the question of, what do I want to be possible on Urbit? The thing that is sort of the clearest to my mind is you should be able to sit down at a computer with an idea to build an app and build it in a couple of days if it's a simple app, and then release it and have it on the network. And it should be able to do a lot more than what a regular PC can do. It should be able to interact with your friends. It should be able to push notifications to your phone. It should be able to do all these different things. And it should be basically like production ready to the point where you could distribute that to that app to your friends as well. And it's not going to break their computer. It's not going to cause them problems. This is related to Ted's what he's talking about with an app that that lasts forever. But more specifically, it should be something that you can build fairly quick, and that doesn't require. I mean, right now there are many apps that exist on the old internet that are whole venture-funded startups with increasingly large teams, and they really should be just some kid writing some code and then releasing it, and it's done. And so in a lot of ways we're kind of there on that, or at least to some level. You can go and you can write an app relatively quickly, at least once you know the system, and release it, and it works pretty well. But it is not production ready, and so my focus and what I think of when I think of what am I trying to do at core development is entirely on how do we get to be sort of that first level of viable for a successful product on top of Urbit. Galen touched on this some yesterday, but basically, once we can get to the point where you could write an app, release it, and feel comfortable with people using it, and that's going to be reliable, that's going to be secure, that's going to scale up as it needs to, then Urbit is, I don't know that it won't be at 0 Kelvin then, but it will be done in some meaningful sense. And then, from there to, I think for Urbit to really succeed, it needs to be the best software stack for building, personal software. And like in the talk yesterday, the distance from that barely viable point to there is very small, because already you can build stuff much faster on Urbit than you can on anything else, at least to the to the same level of functionality. And so, I'm focused entirely on getting to that point, basically.
Thanks, Philip. So everyone else on this stage are big committers to the open source repo, Urbit. And both Ted and Philip have talked a lot about apps and developing these apps. Mark does kernel work, Mark does user space work, Mark does work for apps for Tlon. Also, Mark just writes apps as himself on his own time. And so, who here uses PALs? Does anyone use PALs? How about rumors? What's the fiction one? The invisible
networks?
Did anyone use that?
Hey, good.
Okay, so I'm sure there are more. Those are the ones I know about. But that's Mark.
Yeah, so I'm Mark. I'm palfun-foslup, but apparently everyone already knows that. And as far as I'm concerned, the future of Urbit is already here in many ways. I just want to write software for my friends, for my family, for myself. Urbit is already great for that. You mentioned invisible networks. I'm not going to pause every minute, guys. Come on. You mentioned invisible networks, for example. With a couple of people, we set up a small writing prompt event where it's like, yes, for this entire month, you'll get a writing prompt every day, and we can share the stories we write for those with each other. And it's like a small-scale event, just a group of friends, basically, working on this interactive fiction kind of thing. And I whipped that up in a couple days' worth of work. Urbit is already great for that. There's, like the guys have already talked about some of the things that are still missing on the infrastructure level. There's some parts there where it goes into developer experience as well that we need to spend some time working on. The dependency story is an important one. Right now, if you depend on something else, like I've also, in the application work I've been doing, I've been developing many libraries for painting over the boilerplate code a little bit while we work on a better solution deeper down in the stack. But if you want to use those dependencies, the only solution we have right now is for you to manually copy the files in, which is not exactly ideal. It gets the job done, but after you've done it a couple times, you're like, man, this is slave labor. Don't make me do this. So that's one other thing that I believe people in the community are already working on solving. It's going to be interesting seeing what comes out of that and how we'll eventually integrate that into the kernel. The other thing that Urbit doesn't quite have yet is native interface solutions. This is a very, very broad and very open question right now. Most of the developers on Urbit write JavaScript front ends for their application and talk to Urbit over HTTP. There's a solution that's close to that where you generate your interface in HTML on Urbit and then serve that as a front end. This gets you your interface generating code closer to the data, which already feels very good, but HTML is still somewhat restrictive. It's a space we haven't fully explored yet. You can certainly imagine sort of component libraries in that sense, but if you're doing it that way, you are rather limited in the kind of dynamicity you can get. It's very Web 1.0 style. Oh, here's a form. I click submit. Post request goes out. Result comes back in, and there's my new page. No live updating, no infinite scrolling, nothing. I've been working in half secret for a little while on new terminal improvements. If you want to come around, we're going to have a Tlon, Q&A desk kind of situation?
A demo booth.
Yeah, demo booth. I'm going to be doing in-person demos of some of the new terminal stuff I've been working on, text UI kind of situations. If you're interested in that, do drop on by. It's very early days for that still. Most of the stuff I'm doing right now is just wrestling with the medium, which isn't really the point of this line of work. We had a great great round group discussion the other day with the Holy Grail UI group about what direction this should go in the longer term. It's very open. A lot of it is undecided, and there's a lot of different perspectives on it going around. But my hope is that once we have a better developer experience for the terminal, we can start experimenting with things approximating UI frameworks or UI protocols on that level. Then again, you're staying within Urbit, you're close to the data, and it's going to be very interesting to see how that affects application development.
So Urbit's this diamond that we're exerting pressure on to form over time, kind of like Ted said. And it's Mars computing, you know, in that original blog post that I think all of us have read, and if you haven't, you should. But we're on Earth. And there's kind of a hazmat suit that protects the kernel from all of these realities. The humidity of Miami and, you know, the terribleness of Earth computing. And that's the runtime. And Joe is sort of, I guess you're the de facto and de jure owner of the runtime. That's you.
Yeah.
Joe is also a Hoon expert, also a knock expert, routinely contributes very materially to bugs. Since I got here, actually, just one last story about Joe. There was, I'm going to forget even what it was because I probably didn't even understand it, but there was sort of this naughty bug deep in Hoon that he chimed in with, you know, after having some sort of feverish, non-malarial, because he lives in Vermont, dream of how to fix it, and came in and sort of just did it. But this was running in the background for literally months while these other things that he does more typically were happening.
Yeah, that was at the dentist, actually.
Okay, so it's drugs. It wasn't a fever. Sorry.
No, there was a space leak in the compiler. We'd looked for it for years. And the answer came to me under Novocaine. Anyway, I'll introduce myself. I am Joe, master-morzod. I've been at Tlon since 2018. Found Urbit probably around the same time as Ted. There were certain controversies, cancellations, conferences, other C words. So I showed up, and frankly, I was horrified. I thought these people were completely insane. But they were clearly smart people, so I just suspended my disbelief and promised myself I'd figure out what it was. And as I tell everyone since then, I did. And, you know, was irrevocably changed in the process. So I still don't know, actually. But I'm here.
Awesome. Is there anything you want to talk about, kind of future work or anything that you're excited about?
Yeah, well,
building?
I shouldn't have let Ted go first because he picked the two best things.
That's okay. And we can also...
No, I will. So there's one, everyone gave really good answers to that question, but they were all about developers. And developers are important, but developers aren't the only people in the world. And so the near-term aspect of Urbit, which is related to everything that was said, that I am the most excited about, is actually delivering software that people can depend on that requires, you know, we say zero-click maintenance. Zero clicks might be impossible. The founder always said, it might not be able to have the maintenance burden of your pet rock, but it should be a cactus, right? You water it every couple of months. Watering it in this analogy is probably installing an update to the runtime. Which brings me to the technical things that I'm most excited about in the near term, I think we have solutions for the 2 or 3 things that technically literate critics point at as insurmountable problems with Urbit. You have T-shirts. We've seen the T-shirt. The thing that is on the T-shirt is very simple. That's how it fits on a T-shirt. Naively, it's also very slow. Impractically slow. Can't do anything useful with it without seriously accelerating it in some way. The other big problem that people point to is that the life cycle model. We have this, your Urbit is this complete definition of a computer where its state is absolutely specified by the thing on the T-shirt as all the things that it's heard. To accomplish that, we have to write down all the things that it's heard, and writing things down is slow. So concretely, I'm talking about executing knock, and I'm talking about the way that we realize this single level store, the computer that never forgets anything, which is an event log and a snapshot system. There is a project that many of you have heard about, that Will just mentioned, that goes under the code name New Mars. And it's our skunkworks, basically. And it has generated novel solutions to 2 out of the 3 problems. And the founder actually left us with a solution for the 3rd problem. And
Remind us, what's the 3rd problem?
I'll recap. But we were too scared to do it, so we put it back on the shelf. So these 3 things are the fast execution of knock, efficient incremental snapshotting, and event logging that doesn't make everything even slower than dog slow, because you have to write down each event before you can let anybody see what happened to it. Let me see if I can do these. The trick for the event log is really simple, and that is that when your ship is busy, the events are waiting before you can get to them. They're sitting there. You hear the packet before you can compute it. And so you just write things down before you're done with them. The challenge is that you have to be able to realize just this perfect determinism in all scenarios. And so if you commit to doing something in a particular way, then you have to do it in exactly that way. For snapshotting, this is simpler. Everyone is familiar with the 2 gig limit. There are many ways to increase the size of that limit, but fundamentally you have very important data sitting in memory. You have to get it reliably to disk, or you're falling back to replaying this event log. And then for knock execution, maybe I'll save that part for the demo booth, because I don't think I can do a 2-minute cliff notes. But there's a plan to make that go very fast, which is giving us very promising results. The other 2 things outside of knock are going to be enabled by work that has been in progress for a long time and will be shipping very, very soon. I'm sure everyone also knows that the current Urbit doesn't allow you to truncate your event log, so your event log grows indefinitely as you use the ship. Fanfung-Mockbud, who is in the audience, but has fixed this problem, and that'll be going out in the next release. He's also fixed some major bugs in the snapshotting system that the horrifying loom corruption that no doubt some of you have had to struggle your way through. But the relevance to what I'm saying here is that the nature of the fix for the event log truncation is actually the enabling solution for the event log that can run ahead of compute. And what this means is on a busy ship, the cost of writing down what you're going to do is amortized out to basically 0. They were already sitting in the queue, and so from a latency standpoint, You don't even notice the fact that you had to log them. So that is future work. The log truncation work is coming very soon. Snapshot improvements are coming very soon. Snapshot improvements to enable basically arbitrary size persistent arenas is more midterm. There's other people here working on that. So I am incredibly excited about those things because they're real problems. They're real difficult problems, and critics have had a point. If we want to say that Urbit is going to be for everything, that knock the only legal form of computing, pave the world in nouns, or any of these catchphrases, we have to be able to mean it. And these were basically the last things on my list. So I believed it anyway, but now I can preach it.
Okay, so we can either do sort of like a round robin arm wrestling matchup here, or we can take some questions from the crowd. Okay, that's fair. I didn't say what I was interested in. I'm interested in some of the sort of utopian idealism based upon certain characteristics of my upbringing, which I'm happy to discuss more in depth in person, but it involves hippie parents. And the opportunity for doing your own thing on your own time in a way that doesn't require infinite pseudonyms and anonymous handles and all these other, and like, how the fuck am I gonna get this shit from my old phone on my new fucking phone, and all these other problems that have just got worse over the years. I have at times in my life played with different ideas around identity and sort of physical storage. Didn't really do anything material about them. I don't want to oversell that. And you remember in the early 2000s, you had a bunch of music, and you don't have subscription services yet, and you're like, Christ, I've got all these songs, and what am I doing with all my files, and what's happening? And then, I can just put it in Google Drive, and now you're like, Christ, I'm paying Google $100 for like terabytes of storage because I don't want to keep caring about this, but I can't put the videos up there because then I might actually run out. And it's all these obnoxious problems we have, and maybe we can solve some of those. I don't know if anybody's working the crowd, but I can. So yeah, here, I'll come out to you.
What do you suppose allowed you each personally to commit your valuable time to this before it was necessarily clear that these important problems would be overcome? Did you chase a dream, so to speak, and see how it would work out, or did you have some insight that they would be solvable before you necessarily saw the solutions?
By the time I joined, I had actually done a deep dive on the Urbit white paper that Joe had hosted before either of us had joined, but we were interested in the project, and it was about 2016 or 2017. And there was enough meat in that white paper to really think through, okay, how does the machine code work? How does the language work? How does the OS work? How does the networking work? And you can learn it. You can read it and think it through and talk to people and understand how Urbit works. It takes some time, some effort, but you can learn it. And so it was very clear that a lot of these problems had not been solved yet, but most of them are either problems that have been solved many times in other more traditional systems in exactly the same way that we're going to solve them, or there are relatively clear analogies from existing systems to how we're going to solve those. So there are a few things in Urbit that really are novel, but most of those had already been built and were already working by 2016. And so it's a lot of, sort of most of the parts of Urbit that aren't done are actually the more traditional parts that, so you can look at it and say, yeah, here's how, the Google file system solved, event log it solved event log compaction. Okay, so how they solved event log compaction, which is basically a very similar task to event log truncation, which is one of the things Joe was just talking about. And so it's that just as an example. But you can find similar analogies for most of these things. Language virtual machines, like Edward Amson's work on New Mars, is a sort of translation. So some of that is novel, but a lot of it is a sort of translation of old work that had been done on Lisp and other sort of similar languages and that we're sort of translating into the world of Nock and Nouns and Urbit. So there were only I don't know if there was anything at the time that I thought wouldn't work, and already I think Urbit by 2016 Urbit had a good track record of solving problems that seemed very hard, things like NAT traversal and actually having a transactional event system within the kernel or within the runtime, and a self-hosting compiler for Hoon down to Nock, right? So all those pieces were already there, and so the hard parts, in a certain sense, had already been at least the skeleton of the solution for all those had been written out already.
Yeah, for me it was I joined kind of earlier in my mindset, and then also in the in history of the project. And when I joined, I didn't think it would work per se. It certainly wasn't a motivation for me. For me, it was just, this is a very interesting project. It's a lot of fun to play around with, and I was in a time in my life where I was like, yeah, I'll play around with this for a while, see where it goes. Didn't feel like I could have any opinion on whether it would succeed or what that would even look like. And I mean, I think even now, Urbit is very suitable for just, you think it's interesting? Play around with it, have fun. It's a ton of fun to learn. It's just a very interesting system. It has some novel stuff. It has some stuff that I feel like is easier to learn within Urbit, and then when you see it out in the world, you're like, oh yeah, that's just like that other thing in Urbit, or at least that's been my experience. And then it was only years later that I was like, okay, yeah, I actually think this can work. It's really important that this does work, and that it's the most important thing I can do.
I think I might put it back to the audience.
Well, actually, I'd kind of like to have a second answer to that.
Okay.
So these days I don't usually have deep concerns about can we solve the 2 gig limit? Can we have a user space permissioning system? I don't have these kind of basic concerns about will it work at all. I'm confident we'll get it to work. The thing that I worry about some, and this is just sort of a lot of what we try to address in general with core development, is not just having something that works, but having something that works well and that conforms to the Urbit ethos. So the ethos of Urbit code base is something like, it needs to be timeless, it needs to be minimal, and needs to be elegant. Often we'll know when a module within the kernel is finally in a good state when we can look at it and say, yeah, this doesn't really do anything anymore. A lot of this relates pretty closely to what Galen was talking about the other day about how we want computing to sort of fade into the background, become this imperceptible sort of fabric. And the kernel especially, I would say, needs to do that. So a lot of that has to do with being what we call solid state, right? It should be inert. It shouldn't be sort of doing a lot of asynchronous communication. It shouldn't be doing setting a lot of timers. It shouldn't be sort of waking up all the time doing work. And so it should look more and more like a monolith over time, not in the sense of one single system, but in the sense of like a piece of rock.
An obelisk?
An obelisk, yeah, thank you. And so systems have a tendency to decay over time without sort of active work being put into them. And the whole point of Urbit from a technical perspective is to get out of the big ball of mud that typically characterizes software development. And so, what? Yeah, you need stability for that, but you need minimalism, you need elegance. And so there's a problem when software evolves in a sort of undirected manner, where you end up with more and more software over time. There's the old adage that you can solve anything in software with by adding another layer of indirection, except for the problem of having too many layers of indirection, which is another way of looking at the problem that Urbit solves in general. The number of layers in the Urbit system is much lower than in Linux. So a lot of what we need to do is make sure that as we build these features, we shepherd the kernel through that development in a way that maintains its cleanliness, maintains the aesthetics of the system, which are actually deeply important. Urbit is, among other things, an art project, and it must continue to be that. And so, Balaji was saying earlier that the Urbit development needs to change from being a cathedral to being a bazaar, using the old terminology from the 90s, right, in open source. So the cathedral is sort of a top-down, small organization, relatively closed, and they work like a corporation to push out a piece of software. A bazaar is an ecosystem, sort of many different people working together, sort of and I would contend that actually kernel development must remain a cathedral, and then user space development should be a bazaar. And it already is a bazaar. And so that doesn't mean that we don't want to take in contributions from a larger and expanding group of contributors from many different companies and organizations involved in Urbit. We do. And that's also very important. But it needs to operate in a different way so that we can maintain what Van Jacobson called the thin waist of Urbit. And by analogy to IP and TCP. So there's a great talk by Van Jacobson called Thinning NDN's Waist, where he goes into the history of the IP protocol and why that was how a big part of why that was so successful is that they shrank the number of components down over time. And he gets into how they did that. And that's a lot of what we need to do with the kernel.
One thing that'll happen internally is when there's like a PR going through, somebody will say how many lines of code they deleted, and we'll celebrate that. And sometimes it's hundreds. Anyone else in the audience want to?
Hi. First, thanks for organizing this conference. It's been fantastic for the past couple of days, so really appreciate it. I wanted to ask you, so there's an increasing number of programs, I've heard them called self-hosted platforms as a service. So examples of this might be Unihost.
Can you put the mic more directly in front of your mouth? Thank you.
Yeah, sure. So there's an increasing number of self-hosted platforms as a service that make it, easier to kind of launch your own server, install self-hosted apps, conventional apps. So maybe things like, WordPress or Mattermost, that sort of thing. At some level of abstraction, Urbit can be kind of seen in that light. So I guess I'm wondering, is there any interest in bringing pre-existing open source software, whether Select or all of it, to Urbit?
I'm going to say the short answer is no, right? And I think and the slightly longer answer is, separate from the whole Earth-Mars dichotomy or metaphor, is that Urbit is not a server exclusively, right? It's a network, it's an identity, and it's a computing environment. One thing that when you dig into kind of the writings there, if you will, is that the scarcity of the idea is that's intentional, right? And sort of the strength of that idea is very intentional. It remains not wholly unexercised. I don't know if the Vienna guys are still here, but thanks. Okay, and but that's sort of this whole other territory that we haven't even begun to kind of discuss or explore in a larger way. I'll stop there in the interest of time and getting around, unless anyone has something quick to add. Does that help? Yeah. He works at Salon. He's not.
Actually, I was going to ask a question that you raised.
Well, here's the thing. Everyone's here, right? And so you should ask Edward that question. But
this goes to something that Edward said at reassembly a couple months ago, and that is that due to the nature of the deterministic architecture of Urbit, you guys have actually solved some problems that were thought unsolvable in computer science, and I was wondering if you could speak to that.
I can't.
Which ones?
What?
Oh, yeah. Philip, do you want to talk about static or dynamic linking, or I can talk about it? All right. Okay, so I wrote a Twitter thread about this. I'm Rovnys on Twitter, just my first name. So, how many of you are familiar with static and dynamic linking? Raise your hand. Great. This is a great crowd. So if you don't know, sorry, I explained it more in the Twitter thread. But okay, so very briefly, static linking. Okay, linking is the idea that you have many different pieces of source code written in different files, and you need to take those different pieces of source code, somehow stitch them together, and then turn them into a program. So right, so you have to give either one input to the compiler, or anyway. There's this process is called linking. Just about all languages, all programming languages need to solve this in some way, and there are two basic strategies. The sort of obvious way to do it is called static linking, and what that means is that you take all these files, you stick them together into some kind of data structure, you feed them to the compiler. The compiler is essentially a function. You run the function, and you get this output, which is an executable program. This is the sort of normal, sane way that one goes about doing linking. However, it suffers from a big problem, which is that in practice, a lot of applications share a lot of the same code. So a lot of them are importing the same standard library. So for example, on Mac OS, there's the libc. This is true, right? Yeah, okay. So on Mac OS, libc is dynamically linked, not statically linked, because every program imports it. And so that means that when you're running 25 different apps, each one has a different copy of this library in memory. And that ends up getting big. It ends up using up a lot of your RAM that you want to be using for something else. And so on macOS, libc is dynamically linked, which means that you write the program when you're in such a way that it says, okay, create a sort of most of an executable, but in such a way that when you actually go to run it, the operating system will stitch together just one copy of this shared library with your program, and so they can interact. But that way, all the different programs that imported the same library don't duplicate the memory of that library. There's only one copy of the library sitting in memory. So this ends up being very important, and so a lot of things are dynamically linked, and there's only one really big problem with dynamic linking, which is that it drives everybody nuts. It's impossible to deal with. You may have heard of dependency hell, DLL hell, that's the Windows version of it. JavaScript has its own versions of these hells. Every software system just about has a version of the hell that comes from dynamic linking, because it's fundamentally not deterministic. You write a program and then later the operating system sticks something else into it and you hope that it's compatible.
So how are you going to fix it?
How do we fix this? All right, so what we ended up doing is just leaning on the properties of knock. So knock has something called structural sharing, meaning that you can logically copy a tree, but when you copy the tree, you really just copy a pointer to the tree, and so you don't have to duplicate the memory that stores that tree. And so we just hooked into that, and we did a referentially transparent cache for the build system, which is called Ford, which is also what does the linking in Urbit. And so referentially transparent cache in the sense that the key for that cache specifies everything you need to know to run the build. And so because of that, you get global deduplication of builds. So you get a global deduplication of building a library that could be used in many different applications. And then when all these different applications import the library, you just copy a pointer to the library. But the nice thing about this is that logically speaking, this is static linking. That is how it is expressed. That's what the semantics are. So you get the semantics of static linking, but the memory performance of dynamic linking. So I contend that we've actually solved this 50-year-old problem in computer science.
Hey, we have time for one more, but these guys mentioned they are going to be at the Talon booth, so do feel free afterwards to...
They're also going to be a little bit feral as well, so just grab them.
Thank you guys for the heroic work you guys are doing. You're like totally the unsung heroes of Urbit, so thank you. Just want to recognize that. I want to ask about concurrency, right? So like one of the one of the downsides to this sort of event-driven transaction kind of model is that it makes concurrency kind of hard. Events need to kind of be processed serially and deterministically, and this is like a piece of criticism I often hear about Urbit. I'm just wondering, does Urbit need concurrency in the core? How could it be achieved if that were a goal?
Yes, absolutely. Yes, it absolutely does, and this is a big obstacle. So going back to Ted's first answer about the things that he was excited about, the Arvo interface, Arvo being the kernel itself, fundamentally does two things: peek, which is a read, and poke, which is a write. Events are poked into Arvo. Those have to be totally ordered to accomplish the transactionality, the determinism. Reads don't exist. They don't happen. They're unobservable, except to the reader. They can't change the state. They're pure. So that's the first answer, is factor the I/O in terms of pure reads. The remote scribe protocol is extending those pure reads out over the network. And what that means is, in the topology of communication, if you have a node and lots of people communicating with it, all of that data flow can be expressed concurrently, so long as your runtime is actually capable of it. But it's totally fine in the model. The other thing that we need, though, is within an event, if you have some big piece of work to do, and it can be factored out atomically, you have to be able to kick it out of the loop. This is what every event loop system does in the world. The naive way of doing that is just to kick it out as an effect and ask the runtime to run it and inject the result. That runs into the problem of maybe the result is really big. You have to write down your events. Do you want to be writing down this huge thing? That could be very expensive. And that gets you into schemes where you index back into the effects. Your replay gets a little bit more complicated, but what gets recorded is not the result, but a pointer to the input that lets you recreate it. And so yes, it does need it, and we have solutions for both.
Well, and actually Joe came up, so that was how I thought about doing this in about 2018, and then Joe came up with a better way of doing it later. Yeah, we're running out of time, but ask us later, we'll tell
They're
you.
just for a lot of this stuff already. Reach out to anybody on the panel if you can't find them, and yeah, but just like grab people, mug them today.
Thank you to the core devs.